Electrical safety is very important. Before discussing electrical safety, it's first important to know how electricity works. Current flows from a generating source through conductors to a load. Generating sources include batteries, portable generators, and electric utility supplies. The normal route for electricity is through conductors. Shock occurs when the body becomes a part of the electrical circuit. Electric shock occurs when current enters the body at one point and exits at another. Shock occurs when you touch both wires of an electric circuit, one wire of an energized circuit, and ground, or a metallic part that is hot. The severity of shock depends on the amount of current, the path of the current, and the amount of time exposed. Effects range from a tingle to cardiac arrest, severe burns, and probable death. At 5 milliamps or 0.005 amps, a GFCI will trip. At 20 milliamps or 0.02 amps, muscle contraction occurs. At 100 milliamps or 1/10 of an amp, your heart stops beating. Severe burns occur at 900 milliamps or 0.9 amps. Typical household current can cause death. Grounding protects you from electric shock, safeguards against fire, and protects electrical equipment from damage. At construction sites, the most common electrical hazard is the ground fault electric shock. A ground fault occurs when a hot electrical wire contacts a ground enclosure. In most situations, the fault will trip a circuit breaker or blow a fuse. However, if a break in the ground wire occurs, the worker would no longer be protected unless a secondary safety measure is available. The use of a ground fault circuit interrupter, or GFCI, is one method to overcome ground and insulation deficiencies. A GFCI is a fast-acting circuit breaker that senses small imbalances in the circuit caused by current leakage to ground and in a fraction of a second shuts off the electricity. GFCIs monitor the current to the load for leakage to ground. When this leakage exceeds 5 milliamps, the GFCI interrupts the current.